All right, today I'm joined by Mark Peco. We're going to be discussing NoSQL databases. Welcome, Mark. Thank you so much for your time today.
Thank you very much. Appreciate it.
If you wouldn't mind, just by starting on giving yourself an introduction here on what you do and what brings you to TDWI, perhaps.
Okay, sure. I'm independent. I've worked for big companies over my career, but for the last 20 years, I've been independent. And in that capacity, I joined TDWI's faculty in the early 2000s. So I've been teaching courses at their conferences and seminars for almost 20 years. I'm an engineer by education, and I have to think that data has been the common theme through my career, from automation to consulting, and now I've focused heavily on education.
Very cool. We're very pleased to have you with us on the faculty and here at TDWI Orlando. Again, the topic today is going to be NoSQL databases. I think a great place to start with this topic is what exactly is NoSQL?
That's a really interesting question. And from my experience and knowledge, the word NoSQL really is meaningless. It has many meanings. It be no SQL, not only SQL, but that's not what's important. What's important is that there's a theme that emerges is that the data is going to become self-describing. We don't have to put it in predefined tables. So the theme of NoSQL is the data describes itself, and we can be very flexible because of that. So it's really non-relational in other forms.
That's a really good response. I think that's very intriguing. So why does it exist?
Well, I guess if you go back to the advent of data science and analytics, what people needed was innovation or rapid approaches to analyze data that they didn't even know if they needed before. So if we had to wait for a relational database to be defined in advance, we didn't even know if the data was going to be useful we wanted to analyze. So NoSQL emerged as giving me a flexible platform to store anything I wanted and then commit to it. So I may keep it in NoSQL, but I may eventually migrate certain things to a relational database. But what I think is that it introduces tremendous flexibility and opportunities to store data, change your mind, add it, delete it, and modify it, and not slow down the analytics process.
Very good. So is there only one type of NoSQL database?
No, that's really good to think about. NoSQL is an umbrella term. Depending how you count them, I think what people generally see, there's probably 4 types of NoSQL databases. And it really depends what the common theme of all of them is that the data is organized by what we call keys and values. So the data, because it's self-describing, is that every data element, we call a field, has a key and a value. But there's different ways to organize those keys and values. So the first kind is a key value database, which is simply a list of keys and values. There's a wide column family database, which is a way to organize these things tabularly. There's a document database, which organizes things by hierarchies and like business documents. And the fourth type, which I find the most interesting personally, is the graph database. And data is organized in a network format to help us understand the physical interactions in life.
Well, that's very cool. Could you expand perhaps on that last one? That sounds very interesting.
Sure. The graph database, what kind of bothers me is we kind of lump it under the term of NoSQL as if it's one of the other kinds. But a graph database to me, yes, it is that, but it's also much more than that, because it helps me understand how things are really connected in life, whether it's a social network, whether it's a business process, whether it's an industrial network, or whether it's people driving cars on a freeway. Everything's connected. And so graphs, which is a graph database, represent networks, which is how the real world exists. It introduces all kinds of interesting opportunities to look at how things flow through a network, traffic through a highway system, funds through a financial network, communications through a social network. And so there's all sorts of analytic opportunities emerge because we structure it as a network.
Very cool. So what are documents in terms of NoSQL then?
Okay, so there's confusion because people think of a document like a Word document or a PowerPoint document.
Yeah.
We're talking about the term document is a way that the keys and values are organized. And think of a document loosely around what you might think of as a business document, like an invoice, like a purchase order, maybe like a reservation at a hotel or a restaurant. It contains all the stuff you need for that function to process. So it's saying, what do I need for an invoice? What do I need for a purchase order? What do I need for a reservation? The data is grouped around that. So it really makes the data self-contained to do a business process. So it's closer to how data is going to be reported.
That's very good. Could you perhaps give us a couple of use cases for NoSQL databases, perhaps?
Sure. So, I mean, it started off predominantly to serve the analytics part of technology, and was not originally focused on transaction processing. That's not true today. So the NoSQL databases can compete with or relational databases for transactions, but a primary use case is to serve data requirements where we're really not 100% sure what we need. So it's very flexible to add data, to change data. So things like looking at analyzing any analytic use case, like I used earlier about in a graph. We want to analyze the capacity of a highway system. We want to look at the influential people in a social network. We want to look at the risk factors if something's going to fail in a network, like a bridge is out of commission, it's going to cause traffic to stop flowing. So NoSQL databases give me use cases around networks and around flexible document structures, where I don't have to store all the same data for every document. I store the data I need for that document. And the key thing here is I can do all the stuff in relational. Not that I can't do it, but what it introduces is the flexibility to keep adding and changing my mind as I learn what data I need. Now, there's a downside because it's so flexible. We sometimes could lose control of quality and what the keys we're using for the data. So nothing comes for free. So we need to govern this in a way that we can find the data after we've stored it. So just to summarize, the major use cases are where there's flexibility required, where I don't really know my data requirements, or if my data is very sparse, that this invoice requires this data, that invoice requires a whole different kinds of set of data, I can store them both as invoices because it doesn't care that the data is different across the different invoices.
Very cool. I would say a good question that's coming to my mind here is how many companies or entities are using these databases? Is it pretty unanimously used at this point, or are you seeing it growing or lessening in your estimation?
Well, there's a lot of factors. It's growing, but it's also the impact of the cloud and cloud services. But the mid-tier cloud vendors offer their versions of NoSQL databases in different forms. So it's really serving data science and analytics workflows right now, especially to serve the fact I'm bringing in all kinds of data. I don't know what I need, so I analyze it, keep what I need, discard what I don't need. So a lot of companies use this as analytic use cases, but because the databases now can support transactions, I believe there's a penetration of the relational market. So eventually we may see more NoSQL than not, only because they can do it. So yes, I think it's in a growth mode.
Very cool. Picking up off of that and kind of looking to the future, where do you see this type of technology evolving relative to traditional relational databases?
I heard a quote once that said that when Larry Ellison implemented Oracle back in the 1970s, that if computing was as cheap then and as powerful then as it is now, Oracle would have been a graph database. And I thought about that. That's really interesting because graph databases open up so much possibility because it's much more natural for how the world's structured. My own personal bias is that of the four NoSQL databases, I think the graph database has the most upside, only because if you learn how it works and how it's structured and what it does, it's much more natural to how you analyze things that really work in the world, processes, organizational structures, traffic flow, power grids, social networks, communities. These are all structured, and graph databases are very natural. Now, yes, of course, the relational diehards would say, but you can do that in relational. Yes, you can, but graph databases provide more flexibility, and it's more natural for doing it.
Very cool. I think final question for you before we wrap up. I know you're short on time today, as we all are trying to move around this conference. If someone were interested in getting started with NoSQL databases, what would you say would be a good reason for them to start, and how would they do so?
Okay, again, first of all, is to one of the things you really have to understand is a data structure called JSON. So that's JavaScript object notation. That's how we tend to use keys and values in some sort of a formatted structure. You could also use XML, accessible markup language. That's how we codify data in keys and values. But I would suggest start there, learn how a JSON structure works, learn the syntax. But most of these databases are free. You can either open up cloud accounts with some of the major vendors. You can download their products for free to your desktop and play with them in a personal edition. There's many YouTube videos. TDWI offers courses in this space. There's no shortage of education. and the software essentially can be free to play with. So I start with learning JSON. I'd understand, do some research into the business problems you want to solve, because I really believe we need to know the problem we're going to solve with business domain expertise to say, why is it worth solving this? So learn the problems you can solve, learn JSON, download some free software, and have fun with it.
Awesome. Mark, thank you so much for your time. If you wouldn't mind sharing how people might engage with you further if they listen to this and they might want to reach out and ask other questions, how would they do so?
Sure. Again, LinkedIn. So you can find me on LinkedIn, connect with me there, or I can give you my email. Is that appropriate? Okay.
Sure.
So it's my name. So Mark, MARK, .PECO@gmail.com. Reach out, say hello, and we'll connect. Love to hear from you.
Terrific. Thank you so much, Mark. Really appreciate it.
Okay. Thanks.